All right, alternating series is one of my favorite series. It's one of the easiest ones to work with, and it's going to converge if number one alternates, so that negative one to the n, we'll let it alternate. You got to be careful if it's negative one to the 2n or something like that, or 2n plus 1, that won't actually alternate. Negative 1 to the 2n, it's always going to be even, and it's always going to be a positive 1. Whereas to an odd, it's always going to be negative. So be careful if they mess with the exponent at all. But this is going to alternate. And if we have an alternating series like 1 minus a half plus 1/3 minus 1/4 plus 1/5 minus 1/6 plus 1/7, all the positives are going to add up and all the negatives are going to cancel out. And it's going to have a much easier time of converging. So if you have an alternating series, it converges if it's alternating and the limit of the non-alternating part, a sub n, goes to 0. So this ends up being 1 over n that alternates. Normally, from what I know about the p series, is it would normally diverge. But since I got negative 1 to the n over n, this is called the alternating harmonic series, which converges. So it's much easier to have an alternating thing converge versus a non-alternating series. You don't need quite as much. So when we look at example 3 here, well, first thing we got to make sure is, does it alternate? Well, n plus 1, that just tracks it from being a positive or a negative first, but it's still going to alternate. So it alternates, and does 1 over n to the 1/3, does that go to 0? Well, infinity to the 1/3 is still infinity, so this goes to 0, so it converges by alternating series. All right, well, let's look at the next one. Well, first off, it does alternate, but what's the limit of n squared over n squared plus 3n minus 4? Well, we look at our degrees. N squared over n squared, they basically cancel out, and I get 1. So this one does not. This diverges. So two things need to be true. It needs to alternate, and the whole series has to equal 0. Limit of the whole series has to equal 0. If that limit's something bigger than 0, then it does not converge. All right, we got a couple of rules here, talking about just notation and how to call things. So the first is actually a theorem, and it's absolute convergence. So if you take the absolute value of a series, you get rid of that alternating part, or you get rid of the negative, and that converges, then the normal series also converges. So if you think about it, they're all negative numbers to begin with, then they're going to converge the same number as all the positive numbers would anyway. So if you toss the absolute value on there and it converges, then the series normally would converge as well. If it was alternating, which normally makes things converge easier, if you take out the alternating part by taking the absolute value and that still converges, then the original one had better converge as well. Now, it's called absolutely convergent if it converges with both the absolute value and without the absolute value. So whether you have them or not, it would be absolutely convergent. Now, it's considered conditionally convergent if the normal one converges, but the absolute value does not. And let's look at the first example and see what happens. So this normally is going to converge because it alternates and the limit goes to 0. So this converges, but let's look at the absolute value. The absolute value of negative 1 to the n over n plus 2, well, what's going to happen there is the negative 1 is going to go away, and I get 1 over n plus 2. Does that as a series converge? No, because I'm going to compare that to the p series of 1 over n to the first, which diverges. And I should technically be taking a limit comparison test to be, 100% good, but the absolute value diverges. So it converges, but the absolute value diverges, so it is conditionally. Convergent. All right, let's look at the next one here. What in the world is all of this? Okay, sine of 2n minus 1 times pi divided by 2. All right, well, what's 2n minus 1? 2n would be even numbers. 2n minus 1 would be odd numbers. So this is like 1, 3, 5, 7, 9. So 1 pi over 2, 3 pi over 2, 5 pi over 2. Oh, so this is sine of the odd pi over 2. Sine of 0, 0, sine of 3 pi over 2, sine of 1 pi over 2. Those are either 1 or negative 1. So this is the same as negative 1 to the n. This is going to alternate, and the limit's going to go to 0, so it's going to converge. But it's also, if I take the absolute value of this, you're just going to get 1 over n, which is not going to converge, so it is conditionally. So this sneaky sine of 2m minus 1 pi over 2, it's just sine of odd pi's, which is positive numbers and negative numbers, so they alternate. Something that's alternating, put it over n, that's going to converge. You get rid of the alternating part to it, 1 over n does not converge, so it's conditionally convergent.